Microsoft's DNA Cloud, a zoo inside a test tube. Welcome back, I am Adeline Atlas, 11 times published author, and this is the Quantum Humans series. Imagine storing the entire internet, not in a server farm, not in a satellite, but inside a single teaspoon of liquid. No metal, no silicon, no spinning disks, just molecules. That's not a metaphor, that's DNA data storage, and it's already happening. In this video, we examine how Microsoft, academic researchers, and synthetic biology startups are turning DNA into the ultimate hard drive, and what that means when our bodies themselves become storage devices for code. Let's begin with the numbers. 1 gram of DNA can theoretically store 215 million gigabytes of information. That's every movie ever made, every song ever recorded, every photo ever posted online, all inside a droplet. DNA is by far the most dense, stable data storage medium known to science. Unlike hard drives, it doesn't degrade in decades. It can last thousands of years if stored properly. And unlike cloud servers that require constant energy and cooling, DNA is passive. It just sits there, holding code. This is not speculative. In 2016, a team at Microsoft and the University of Washington successfully encoded digital files, photos, videos, even software, into synthetic strands of DNA, and then retrieved them with 100% accuracy. Since then, Microsoft has been quietly leading a race to build the first DNA-based cloud storage system. Their prototype, nicknamed the DNA Library, stores information using 4 chemical bases: adenine, cytosine, guanine, and thymine, just like natural DNA does. The digital ones and zeros are translated into sequences of those bases, which are then synthesized and stored in test tubes. To retrieve the data, the process is reversed. The DNA is sequenced, the letters are decoded, and the original digital file is reconstructed. While the process is still slow compared to traditional servers, the stability and density of the medium make it ideal for cold storage, the digital equivalent of a deep vault. But Microsoft isn't alone. Startups like Catalog DNA, Twist Bioscience, and Evanetics are building systems to mass-produce DNA storage at scale. Catalog has already developed a machine that can write terabytes of data into DNA daily. Twist is working with pharmaceutical companies to store medical records, compound libraries, and genetic data in encoded DNA archives. The US government is watching closely. DARPA and IARPA have both issued grants to develop DNA-based national data storage systems that could outlast infrastructure collapse or digital decay. Why does this matter for humans? Because if DNA can store the internet, it can store you, your identity, your memories, your medical history, your voice, your past. Already, research groups are experimenting with encoding personal data into living cells. In one famous case, scientists encoded an entire GIF, a short video of a horse running, into the DNA of E. coli bacteria. The bacteria reproduced normally, passing the video to future generations. This was the first living biological archive. But it won't be the last. In the near future, it may be possible to encode passwords, birth certificates, or even intellectual property into your own cells, embedding ownership into biology. Picture a musician embedding copyright metadata into her own blood, or an activist smuggling documents in DNA-coded skin cells. That's not science fiction, it's biosecurity. This raises profound questions. If your body contains data, who owns it? Can it be copied? Hacked? Could someone extract proprietary code from your sweat or spit? The legal system isn't ready for this. The very concept of genetic privacy will have to be redefined. Then there's the issue of biological computing. If DNA can store data, can it also compute? Researchers at Caltech and Harvard are building DNA computers, systems that perform logical operations using DNA strands instead of electricity. These machines can solve math problems, trigger chemical reactions, or control nanoscale robots. The ultimate goal is a world where DNA doesn't just store data, it processes it. Imagine a tiny organism that detects disease markers in your blood, compares them against an onboard DNA database, and releases the correct medicine, all without a chip, battery, or internet connection. That's a DNA robot, and prototypes already exist. We're heading toward a future where biology and computation merge completely. Our bodies won't just be containers for life, they'll be programmable hardware. Let's explore the implications. First, there's immortality of knowledge. Traditional storage media degrade, CDs rot, hard drives crash, the cloud requires servers, power, and geopolitics. But DNA survives. It has already lasted for 100,000 years in Neanderthal fossils. It could last 1,000,000 years in ideal conditions. In an age of digital fragility, DNA offers permanence. Second, there's biological citizenship. If your data, bank records, legal documents, education can be embedded in your DNA, then your identity becomes inseparable from your biology. You are your passport. This is already being discussed in secure identity frameworks and decentralized medical record systems. But it could go further: blockchain meets biochain, access rights enforced by blood scans. Third, there's DNA malware. In 2017, researchers at the University of Washington demonstrated that it's possible to encode malware into synthetic DNA. When that DNA was sequenced by a vulnerable computer, the malware executed, hijacking the system. That was a proof of concept. But it showed that biological code can carry digital attack vectors. As we merge tech with biology, new forms of hacking will emerge, ones that exploit the literal building blocks of life. Let's talk about humans as living hard drives. In 2024, an art installation titled I Am Memory featured a volunteer who had a poem encoded into his white blood cells. The poem replicated with every cell division, an invisible text traveling through his bloodstream. He became a living archive. Other artists are encoding music, love letters, and entire books into skin cells, creating what some call biological NFTs, unique, embodied expressions of ownership and identity. In the near future, you may be able to choose what memories to preserve in your DNA, not figuratively, literally. As brain-machine interfaces evolve, it may be possible to extract neural signatures of core memories, convert them to binary, and encode them into dormant genetic sequences, your life story, stored in the double helix. This could reshape everything from family legacy to criminal justice. DNA could become evidence, not just of ancestry, but of experience. You didn't just live, you logged it. So where does this end? The ultimate convergence is what researchers call post-biological computation, a state where data and life are indistinguishable. A world where your cells compute, your memories are molecular, and your body is both machine and archive. In that world, uploading your mind may not require a server. It may only require encoding your essence into something that grows. A zoo of humanity, inside a test tube. Hi, I am Adeline Atlas, 11 times published author, and SOS, School of Soul has a brand new series, the AI and Future Technology series. Look, you know the world is changing. And no, it's not going back to normal. Normal is over, and what's coming next is beyond anything we were prepared for. The School of Soul, AI and Future Technology series includes 319 videos on 1. The Download Society, How Data Has Replaced Destiny. 2. Predictive Future. Your next moves aren't random, they're forecasted. 3. Social Credit Systems. The behavioral economy now governs access. 4. Hive Mind. Synthetic telepathy and collective algorithmic control. 5. Nanobots inside you. Medical, military, and programmable intrusions. 6. Grief Tech. AI-fueled digital resurrection and simulated comfort. 7. Uploading your mind, consciousness transfer, and data-based identity. 8. Deep fakes plus AI clones. The replication of reality and identity theft. 9. Quantum humans. The merger of biology with quantum systems. 10. Digital afterlife, where your data goes when you die. 11. Resurrection science, reviving life through synthetic methods. 12. Immortal science, the end of death as we know it. 13. Longevity science, gene editing, anti-aging, and bio-upgrades. 14. Designer babies, engineered perfection before birth. 15. Artificial wombs, birth decoupled from the female body. 16. 3D printing, printing organs, limbs, and even humans. 17. The humanoid era, the rise of synthetic beings among us. 18. Legacy humans, the slow phase-out of unmodified analog people. 19. Smart cities, algorithmic environments that watch and decide. 20. Cloud-based societies, citizenship without borders or bodies. 21. Hackable humans, emotion, memory, and behavior under code. 22. Biometric scanning, your body is your password and your prison. 23. Sex tech, intimacy reprogrammed by machines. 24. Extinction of gender, fluidity, deletion, and design of identity. Every topic is fully explored with real-world technologies, patents, case studies, ethical analysis, and future forecasts. These aren't someday discussions. This is already happening. Join the SOS School of Soul Vault to overstand the future before it's implemented on you.